Hi everybody, welcome to your energy notes. This is our last set of notes for the year and our last topic in Unit 3. So go ahead and make sure that you have your name written down, class period, and the date, and that you write down your essential question. What is energy and how do we measure it? Go ahead and take a second to think about what you know about energy and what we could mean when we talk about measuring it. On the next box, you're going to write down the definition of energy, which is the ability to cause change or do work. The unit of energy that we're going to use for physics is joules, which you might have seen before when we talked about work. Work is a type of energy. If you talked about energy when you were talking about what is energy, what you knew about, you might have talked about solar power or electricity, or energy that we get from our food or anything like that. Those are all types of energy. For this unit for physics though, we're going to talk more specifically about the energy we use to cause change or to do work. So take a second to pause the video and think, what are some different forms of energy? Okay, what are these pictures trying to tell you about what the forms of energy might be? In physics, we use two specific forms of energy, so try to think about what could those be. All right, one of the forms of energy that we're going to talk about is kinetic energy. Kinetic energy is energy due to motion, so that means energy that is caused by something that's moving. Okay, so the equation that we're going to use for kinetic energy is 1/2 mv squared. M stands for mass, and V stands for velocity. So go ahead and take a second and make sure you have those written down on your paper. M is mass, and V is velocity. So one thing we want to know is, what is the kinetic energy of something that isn't moving? So if we're not moving, what is our velocity? Well, since our velocity is 0 when we're not moving, and anything times 0 is still 0, then your kinetic energy is going to be equal to 0. And if you think about our unit is joules, so 0 joules. You might recognize this answer because when we talked about something that had no motion, we said it had no work. And we also said that if it had no work, the number for work was going to be 0 joules. So since we talked about how work and energy are connected, you might remember that joules is the unit of work, same thing with the unit of energy. All right, a little practice problem. So a baseball with a mass of 0.15 kilograms is moving with a speed of 40 meters per second. What is the kinetic energy? All right, so the first thing you want to do, just like we always do in calculation problems, is figure out what are the 3 things we want to find, or 4 things, depending on what problem you're looking at. Kinetic energy, mass, and velocity, in this case, are the 3 things we want to know. On the last slide, we talked about how kinetic energy was 1/2 mass times velocity squared. Ooh. Squared. There we go. In this problem, you want to ask yourself, what is the mass? So the mass here is 0.15 kilograms. And our velocity, of course, is the other number, 40 meters per second. Okay. Now, what we want to do, just like always, is we want to plug in our numbers. So KE equals 1/2 times 0.15 kilograms times 40 meters per second squared. So now you're going to take out your handy dandy calculator, which I need to go grab. And you're going to plug in your numbers, okay? I got 120. Be careful when you're putting this into your calculator because sometimes it's difficult to make sure that you put the squared in right. So what I did is I did 40 squared and then times 0.15 and then times 0.5. Then last thing I need to think when I'm doing this practice problem is what is my units? And here we have joules. Oh, joules, there we go. All right. Second type of energy that we're going to talk about is called potential energy. This is energy that is stored or energy that is not currently being used. One example of this is chemical potential energy, which is energy that is stored in chemical bonds, like ionic and covalent bonds that we've talked about before. Examples of this would be food, gasoline, and batteries. So if you think about maybe that bag of chips you have in your backpack, that food has energy, but it's not energy that's being used yet because you haven't eaten it yet. Once you eat it, your body's going to turn it into energy, right? Before you eat it, that energy is stored in the food, waiting for you to use it. Same thing with gasoline. Gasoline has energy stored in it until your car burns it and turns it into kinetic energy because your car is moving. Batteries, they're sitting in your drawer. They have stored energy until you put them into something that they're going to be used in. The second kind of potential energy is called gravitational potential energy. And for this one, it is energy due to the gravitational forces between objects. So on your paper, there's a little B. Make sure you write down the definition of gravitational potential energy. And also, for letter B, that an object higher up has more objects. Let's say this. Objects higher up have more gravitational potential energy. So here's these kids on a roller coaster. When they're way up here, they have more gravitational potential energy when they're down here. And once they're up here, they have more than down there, but they have less than here, right? This guy's on a swing. When he goes back here, he has more gravitational potential energy. Then he loses some of it, and then he gains some again because up here he has more potential energy of movement. The equation for calculating gravitational potential energy is mass times gravity times height. So on your paper, there's GPE equals twice. The first time you're going to do the words, and the second time you're going to do the letters. Mass times gravity times height. Don't forget our number for gravity is always the same, 9.8 meters per second squared. All right, so for this question, which ball has the higher gravitational potential energy? I want you to imagine a ball that's on the table in front of you and a ball that is on top of the cupboard behind you. So the wooden cupboard way in the back of the classroom, it's on top of that. Which ball has higher gravitational potential energy and why? Pause the video real quick and write down an answer. All right, no matter what you predicted, we're going to go ahead and calculate the gravitational potential energy of each ball. So let's say the mass of the ball is 0.05 kilograms. Okay, fill those in on your paper. We know the gravity, obviously, right? That's 9.8 meters per second squared. All right. Now, imagine what the height is of the table in front of you. What do you think it is? Maybe 1 meter? And then the height of the cupboard at the back of the classroom? Let's say that's 2.5 meters. Go ahead and calculate the gravitational potential energy of both the table and the cupboard and write it down right here on your paper. All right. So we're going to do 0.05 times 9.8 times 1 for the table, and we're going to get 0.49. Don't forget this is energy, so what are our units? Joules. For this one, we're going to do 0.05 times 9.8 times 2.5. And this time we get 1.225 in joules again. So if you predicted that the cupboard would have a higher gravitational potential energy, then you were right. All right. That's a great stopping point for our energy notes. What you're going to do now is get the energy practice worksheet. So it should say kinetic and potential energy practice on the top. And you're going to calculate 6 different problems. Make sure you think about, is it kinetic or potential energy? And then calculate whatever it is that they're asking you to calculate, which I think for most of them is just the energy. Okay? When you're done, I'm going to post another video that has the second half of the energy notes. If you have the time today, you should finish the notes. If not, you should finish the practice, and then you're going to do the notes tomorrow when you get to class. I hope you have a great day.